Alright, so I said in my last video that the could have been a train wreck, and it turned out okay. This one might really be a train wreck though, because I haven't done this in a little bit, but I think I should be able to get this. If you hear any noises, there's a class in the background, so that's just to be expected, but it shouldn't be too loud. So I have ax squared plus bx plus c. This is the standard form for a quadratic equation. You've probably seen it before. When you talk about it in math class, they'll say, a is coefficient in front of x squared, b is the coefficient in front of x, c is the just the constant that gets added. Now, what happens is we're trying to again solve for x. And I said last time that if you start general, then you can, if you solve general, then you can solve all the specifics, right? Like it doesn't do me very much good to, like on the last one, right? I think I still have it up, maybe. Yeah, this was the last problem I did, and it's like, okay, yeah, I got the answer. So I've solved for, if I have x squared minus 8x plus 5, if I record this, I'll have that again, right? And I don't have to do that one again. I can just say, oh, well, just do this real quick. But that's not the case here. I want to do very generic, a very general solution, and see what I get. So let's look at how to solve for this. First of all, again, we're using this complete the square. I want to make this look like that. And the first thing I'm going to do is get rid of this c. So the very first thing I'm going to do is subtract c from both sides, minus c and minus c. So now I have ax squared plus bx plus bx equals minus c. Now I want to get rid of this a because I want x squared, right? I'm trying to make this look like that. So I want a instead of x squared. So I'm going to divide every term by a. And that's a very important part. You have to do every single term. You can't forget to do something. So this is divided by a, divided by a. And I'm using a capital A, which is going to be important in a minute. I'm using capital A. Alright, so you divide it, and when you divide this, that quite simply just becomes x squared plus b over a times x equals minus negative c over a. Okay, now we're getting somewhere. Now this first term already looks like that. Now the second term is going to be equal to this. So I'm going to set, again, just like I did on the last one, I'm going to set these two terms equal to each other and try to solve for a, because that's what I want. So off to the side, I'm going to say that 2ax, and notice it's a lowercase a, is equal to, so this term should be equal to b over ax. And I want to solve for this lowercase a. So just like last time, I'm going to divide by 2x. Divide this by 2x. Alright, so over here, 2ax divided by 2x is just going to be a. So by b over ax divided by 2x. I don't want to spend too much time on this, so understand that the 2, right, is going to go in the bottom, of course, because I'm dividing, and the x's are going to cancel because I'm dividing by x, and there's an x in the top and bottom. So they're going to cancel, and I'm just going to be left with a is going to be equal to b over 2 capital A. This is what a is equal to. So just like last time, now that I know a, I need to figure out what a squared is. Well, last time was easy because it was like negative 4. So it's pretty simple. But now to square this a, I'm going to just have to square the top and bottom. So a squared is going to be, on the top I have b squared, over, on the bottom, 2a times 2a is 4a squared. This is a squared. So I want to add, notice I have x squared plus 2ax, we already have that. But now I need to add a squared to both sides, and a squared is b squared over 4a squared. And it's going to get really ugly. Like really ugly, but at the end it will look okay, and I think we'll get to a pretty cool concept. So I have x squared plus b over ax is equal to, sorry, and I should erase this just so you know this is squared. I don't know, it looks a little sloppy, but it's important that you see it's squared. X squared plus b over ax equals, or so, oops, messing up. See, you hear the train. All right. B over ax, okay, plus a squared. So now I'm going to add a squared. Well, a squared's ugly, but I'm still going to add it. Plus b squared over 4a squared. Alright, and this is going to be equal to, I have b squared over 4a squared minus c. Alright, over a. Whoops, I almost messed up there. Minus c over a. Okay, so all I did was take b squared over 4a squared minus c over a, because that's what I have. I'm going to do a little bit of combining over here. On this side of the equation, right, I'm going to give them like, I'm going to combine them, so I have to make sure they have a common denominator. Well, the common denominator between 4a squared and a, I hope you can see that I'm just going to have to multiply, I'm going to have to turn this into 4a squared. So I multiply by 4 and a on top and bottom. Alright, so let me write that out. I'm not doing anything on the left-hand side. I will get there in a minute. It's about to look really nice in a second. Well, kind of nice. Plus b squared over 4a squared. And this is going to be equal to, okay, now, when I make this, right, I'm going to multiply this to get the bottom. I'm going to have to multiply the bottom to make it 4a squared by 4 and a. I've got to do the top by 4 and a as well. So I have b squared over 4a squared minus, okay, multiply the top and bottom by 4a by 4a. So I have 4ac multiply over 4a squared. Alright, now we're going to start making this look nicer. Okay, so this left-hand side, now that I have it written like this, I can write it like that. That's the whole purpose. We have completed the square, therefore we can use this special form to write it like that. So I'll do that in blue here. Alright, so this now looks like, instead of this whole thing, this whole side, I'm going to write it as x plus a squared. So I have x plus b over 2a. Remember, that's what a is equal to. Little a is equal to b over 2a squared is equal to, if I clean this up, I can just combine these now because they have like terms. So I have b squared minus 4ac over 4a squared. Alright, so now that I have this, I'm going to take the square root of both sides, right? Because I'm trying to get this by itself. So I'm going to take the square root of this side and the square root of this. This is where it's going to start getting ugly, but it's about to look nice. So when I take the square root of this, obviously that side's pretty easy. It's just going to be whatever's left in this middle. So you're going to have x plus b over 2a is equal to, on the other side, you can think of this as I take the square root of the top and the square root of the bottom, right? So the square root of the top is not nice. This minus sign means, I know you might want to say, well, I can take b because b is the square root of b squared, and you're right, but the minus sign means that you can't do it because you'd have to subtract first. So on the top, you really just have square root, you just have to leave the square root there, b squared minus 4ac over, now the bottom you can square really nice. Square root of 4 is 2, square root of a squared is a, so 2a. And don't forget, we took the square root, so there's actually two numbers that'll give me that when I square it, as ugly as it is. It's either plus or minus this. Alright, I'm about to erase a lot of stuff over here because I need more space. So if something is important, you feel like you need it, make sure you write it down before this point. Actually, maybe I'll erase up here because we already have this a stuff. We're pretty much done with the a stuff. Okay, I'll erase up here because we know what that is. Alright, so up here, so now we're going to go up here just so you don't get lost. Alright, so I have this, right? Well, I can, to get x by itself, I'm going to subtract b over 2a. So x is going to be equal to, instead of I could write this minus b over 2a, or I could write, do you remember this plus minus stuff? And that doesn't look very nice, but it's plus minus. Alright, so I have negative b, right, because I'm subtracting, or in other words, I can add negative b over 2a is the same thing. Notice, maybe I should do that. I'll just write a. Negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. Well, hey, these are the same thing. That's nice, right? So we get lucky every once in a while here. And so this becomes x equals negative b plus or minus the square root of b squared minus 4ac all over. Now, if you will let me, and you see I already did, actually a long time ago, started writing a as lowercase a when I shouldn't really have done that, but okay. All over 2a. If I go back, these should all be capital A's. It's not that big of a deal. Just know that the little a we use is not actually in the equation anywhere. It's just for our reference so we can figure out how to complete the square. And this is what I get. Now this probably looks familiar to you. I mean, I hope it does. This is called the quadratic formula. And you may say, well, Mr. King, what a waste of time. Why in the world did you spend the time doing that when you could have just told us the equation? Well, the whole reason I did it is because I want you to see that, like, I don't know, I think there's this like misconception about equations that like they just come from books or something. Like, they don't come from books. They are true because you can see that they're true. You don't have to be told, which is probably what you've been told in the past, use a quadratic equation, it works, and nobody ever told you why it works. But there's a reason why the quadratic equation works, right? I mean, someone actually had to figure this out. And it actually makes you appreciate, you know, how smart people are in the past. A lot of times we think that, like, oh, people in the past were dumb because they thought the earth was flat, or they thought that the sun was, you know, went around the earth or something like that. You know, we kind of have this bias, but they're actually just as smart. And if you can know their name at this point, probably smarter than anybody or living today, probably. So, anyways, the point is that I want you to see where this equation comes from. Yes, we can use it, and I'll probably show you another video of how to use it, but it's important to know, like, that this actually comes from something that is true because you could do it yourself. I mean, it's a lot of algebra, but if you start, again, we just started with ax squared plus bx plus c, and we set it equals 0, and we used the complete the square to actually solve it ourselves. And so if you complete the square, you get this general format, and then you can use this general format to complete the square for any problem from here on out, using a, b, and c as the coefficients on the numbers. And I'll show you how. But anyways, just wanted you to see where this comes from and kind of like appreciate how we have it, right? I mean, somebody, again, some smart person came up with it. So I think that's it.